Welcome to Proving the Concept, the podcast where we dive into the weird, wonderful, and often bizarre world of science and technology. Today's episode is titled Lost at Sea. No, it's not about a shipwreck. It's about the speed of light, symbolised by the constant c, and why this fundamental value is so crucial in the world of physics, cosmology, and beyond. We'll explore the significance of c in scientific calculations, how it shapes our understanding of the universe, and we'll wrap up with a look at a remarkable female scientist whose research into light changed the course of science forever. To start things off, let's define c. The speed of light, c, in a vacuum is approximately 299,792 kilometers per second, or about 186,282 miles per second. This is not just a fast number, it's a cornerstone of modern physics. Represented by c, this constant is the maximum speed at which information or energy can travel in the universe. Light speed in a vacuum doesn't depend on the motion of the source or the observer. This concept, crucial to Einstein's theory of relativity, radically changed our understanding of time and space. Experiments such as Michelson and Morley's attempt to detect the luminiferous ether in the late 19th century confirmed that the speed of light remains unchanged regardless of directional motion. C plays a foundational role in Einstein's equation E equals mc squared, connecting energy, E, mass, m, and the speed of light squared, c squared. It tells us that mass and energy are interchangeable and that even a small amount of mass holds an enormous amount of energy, which forms the basis of nuclear power and astrophysical phenomena. Other applications that you may not be aware of include GPS. GPS systems rely on the constant speed of light to provide accurate information and location data. In astronomy, light years, which is the distance light travels in a year, is used to measure cosmic scales. And finally, communication technologies, including fiber optics, use the principles of light propagation in order to communicate signals. C acts as a speed limit for everything in the universe. Nothing with mass can reach or exceed the speed of light due to exponential increases in the energy required. In addition, Einstein's theory of relativity demonstrated how the speed of light influences time and space. As an object approaches the speed of light, time for that object slows down relative to an outside observer. This has been experimentally confirmed with atomic clocks on high-speed aircrafts. And C is not just an important constant in the universe. It has some really fascinating additional implications that we've not even touched on yet. Cherenkov's radiation being one of them. While nothing can exceed c in a vacuum, particles can exceed the speed of light in a medium such as water. This produces a distinctive blue glow seen in nuclear reactors. When it comes to black holes, the event horizon of a black hole is a region where the escape velocity exceeds the speed of light, effectively trapping anything that crosses it. Finally, the Fermi paradox. The speed of light also limits our ability to explore the cosmos. The vast distances involved mean that signals and spacecraft take decades or centuries to reach even our nearest stellar neighbours. To end our episode, let's shift focus to Mary Somerville, an extraordinary woman in the history of science whose work touched on the science of light and its properties. Somerville, born 1780, died 1872, was a self-taught polymath who excelled in mathematics, astronomy, and physics. She translated and expanded Pierre-Simon Laplace's Mécanique Céleste, making it accessible to English-speaking scientists. Her work was pivotal in introducing Newtonian physics to broader audiences. While Somerville didn't work directly on the speed of light, her work explored optics and light phenomena in astronomy, including planetary motion and the behavior of celestial objects under Newtonian laws. Her studies laid the groundwork for future explorations of electromagnetic radiation, including James Clerk Maxwell's equations. Somerville was so influential that the term scientist was coined during her lifetime, partly in recognition of her work. She became one of the first women to join the Royal Astronomical Society and inspired generations of female scientists. To sum up, the speed of light isn't just a number, it's a fundamental aspect of our universe, shaping how we understand everything from the smallest particles to the farthest galaxies. Today's exploration of C hopefully illuminated why this content has fascinated scientists for centuries. And as we've seen through the work of pioneers like Mary Somerville, the pursuit of understanding light has been a collaborative effort across generations, laying the foundation for much of the science and technology we take for granted today. If you enjoyed this episode, don't forget to subscribe to Proving the Concept. Share this episode with a fellow science enthusiast, and join us next week as we delve into another curious corner of the scientific world. This is Sarah Goffin, and you've been listening to Proving the Concept. Stay curious and keep exploring.